Welcome to Rich Planet TV. I'm Richard D. Hall. Now, in previous shows we have discussed NASA's Apollo moon missions and presented a comprehensive set of evidence suggesting the Apollo crafts did not land on the moon. If you contend that statement, then please watch these two Rich Planet TV shows and see if you still hold that view after you've watched them. Now, in recent months I've been collaborating with researcher Douglas Gibson, who has been investigating more of NASA's claimed projects, namely the Mars exploration missions. Starting in 1976 and up to the present day, NASA have allegedly landed a series of landers and rovers on the Martian surface, which have allegedly sent back photographs and other data to the Earth. Now, I've been working on a hypothesis with the help of Douglas Gibson, which is now running at 50 pages, and you can download it from this link, and it is entitled A Hypothesis: The Opportunity and Curiosity rovers are situated on Earth. In fact, more specifically, the Mars exploration rovers are not situated on the surface of Mars and never left the Earth. As I say, you can download this 50-page document, this hypothesis, from the link on the screen. How many other TV shows would you get a 50-page hypothesis of evidence to back up what we're talking about? Now, here to discuss the claims in the hypothesis is researcher Andrew Johnson. Welcome, Andrew.
Thank you very much for inviting me, Richard.
Okay, now I mentioned the moon there, Andrew, and you're, I would say, convinced as you can be that the Apollo never went to the moon. And we've gone through a lot of that evidence as to why you think that. Where do you stand on these Mars missions, Andrew?
Well, it's very interesting to think about because, you know, I have done talks about the Mars missions as well, as you probably know, and some of the viewers perhaps have had a look around on the websites and stuff. So it kind of, you know, once you've broken through the Apollo barrier, if you want to call it that, and you realise that there's no possible way that they could have done what they did, what they claim to have done on the moon, then, you know, you do have to open up yourself to the idea that perhaps because of similar complications with technology, maybe these rover missions, you know, are not as claimed, certainly not as claimed. Mm-hmm. And kind of, I suppose, you know, you've rightly gone forward with your document mm-hmm. to try and explore where we get to when we look at the evidence and try and study it a bit more deeply with this deeply skeptical mindset that we come to, having found out some of the huge problems with the Apollo record.
I found the more I looked, the more the official version of the photographs, the official story behind them, started to fall apart. Right. And it's been 18 months now, and everywhere I look, it's the same as the Apollo missions. I know most people still believe we went to the moon, but if you look really carefully at any single aspect of the science, it just comes apart. In the
introduction, I set out the reasons why the reader should not just dismiss this hypothesis, because a lot of people will do that. And the reason they'll come up with is they'll say, well, why would they do that? There's no logical reason why they would possibly fake a mission to Mars. Well, let's look at the evidence before we decide why they've done it. Let's look at what happened before we look at why they may have done it.
Always a good method, yes.
Yeah, so investigation before condemnation. And we're going to do some of the investigating today. We'll just start by having a quick look at previous alleged missions to Mars. Now, we've got, from 1964 up to the present day, we've got a lot of attempted Mars missions, the majority of which actually failed. Yep. Most of these were either flybys or orbiters, and we've got a number of craft which are currently allegedly in orbit around Mars. It's all in this table on the screen there, and we've got a number of craft which have landed on Mars, starting with the Viking mission in 1976. Just tell us a little bit about the Viking mission, Andrew.
Yeah, so the Viking mission arrived at Mars in 1976, consisted of 2 orbiters and 2 landers, and they were landers rather than rovers. So they, you know, once they got onto the surface, they stayed in the same place. Mm-hmm. Those missions cost $1 billion. Mm-hmm. So, you know, going back to 1976, that's an awful lot of money. Mm-hmm. And they had colour cameras on them. They had a laboratory, chemical laboratory built into them. So one of the projects was to send an arm out into the soil, dig some soil, pull the soil into the, or dust, whatever you want to call it, pull it back into the probe and drop it down into like a sort of chemical analysis laboratory. And they did this labeled release experiment and so forth. So, quite sophisticated probes. The missions we were told they were a success. Everything worked. They landed where they were supposed to land, and we got quite a lot of good quality pictures from them.
Right.
It was that mission which first photographed this alleged face on Mars from orbit, not from the surface. They photographed that from one of the orbiters in the region became known as Cydonia.
All right, well, we'll come on to some of the photographs which appear to have been tampered with from the Viking mission. Now, they conked out in the early 80s, they lost their power, what have you, and then we've got a gap up until the mid-90s where we have Pathfinder, and you can see the various different sizes of what were called the rover missions. So these are vehicles which can allegedly move around the surface of Mars, starting, as I say, with Pathfinder in, I think it's 97.
That's right, 97.
Right, okay, so that only lasted for a year or two.
Yeah.
Then we've got another gap to the mid-2000s where we've got Spirit and Opportunity, which were a pair of rovers, which lasted lasted a good number of years. In fact, the Opportunity rover is still allegedly active. Is that correct? Yeah. So that's, we can see on the screen there the Opportunity rover, and then we then had the Phoenix
lander.
That was just a
lander. That's
lander.
Right, that was, that only operated, I think, for about 3 months or something. You've got that on your graph there.
Yeah.
So
and then the most recent one, which is Curiosity, which we're going to look at the Curiosity and the Opportunity rovers, which are allegedly still
sending back pictures from Mars. Allegedly, yes.
And moving around the surface of Mars. Now, we're just I've got a section on the power ratings of the Opportunity rover, and in the document I compare it to a mobility scooter, because the weight of the Opportunity rover is 185 kilos, which is probably 2 largish people. So it's reasonably heavy.
Yes.
So you would imagine, if you were to compare it to, let's say, a mobility scooter, which I think is probably a good comparison.
Yes.
Obviously, things weigh less on Mars. I think it's a factor of 2.6 times less on Mars. So it's maybe not 185 kilos equivalent load, but a mobility scooter maybe has let's say an 80 kilogram person. It's comparable. Now, a mobility scooter typically consumes around about 500 watts of power. Now, the Opportunity rover is rated at just 100 watts, which is no more than a sewing machine. So, in the other thing which I go into detail in the document is how the batteries are charged with just 2 solar panels, which are delivering just 100 watts only for 4 hours a day, and this system has lasted for 10 years. Now, just think of your laptop battery, right? Because it's probably comparable. Or maybe something slightly larger. It lasts in 10 years of charging and discharging.
The life of the batteries, because the Opportunity rover is supposed to have been roving around on Mars now for 10 years, powered by one rechargeable battery.
Lithium-ion battery.
Yes, and since when did those last 10 years?
You take those power figures and it does make you scratch your head a little bit. Of course they will argue, you've got highly optimized electronics and drive systems, and we use very low friction bearings in the motors, it's been specially designed for this project and so forth. But when you do the numbers, you start to, like you say, the 100 watts for 4 hours a day, and then also the solar panels, if they're providing 100 watts of power allegedly for, as you say, 4 hours a day, it doesn't seem very much. And also the thing that came into my mind is these things are on Mars, so the sunlight is going to be 20, 30, 40% weaker there. Allegedly the atmosphere is more dust laden, so how much more efficient have those solar panels got to be than they would have to be on Earth.
I mean, here's another interesting fact. The rover's operating temperature is -40 to +40 degrees centigrade. So presumably they've been tested to operate in that range. The average surface temperature of Mars is estimated to be -55 degrees C. That's the average temperatures of Mars. At the equator, which is obviously the hottest point, temperature varies from 20 degrees C maximum to -73 degrees minimum. so the temperature that they're on Mars at, -73, is way below the minimum operating temperature. So,
and that's right. And then you also consider it in terms of, if anybody has ever taken their radio out into cold weather, or a torch, trying to switch it on, you'll find that the battery performance at those sorts of temperatures is very much reduced. And it's, you know, it's literally got to put it in your pocket to get the battery going again with a pocket torch or whatever. Anyone can try that. So how are they getting this power system to work?
So the types of batteries used is a lithium-ion battery. So it's nothing special. It's what you would find in a lot of laptops and mobile phones, and it's lasted over 10 years, being charged and discharged probably every day. And they're only charging it for 4 hours a day with a 100 watt max probably solar panel. So,
and I mean, I've pointed out with the Apollo missions, the Apollo rover that they used, the battery technology on that was operating way out of the specified temperature on the high end, you know, on the moon, you know, and that's in their own documents. So yeah, you've got some serious questions here, certainly.
And you know, if we just go back to the comparison that I've made in the document, imagine putting a mobility scooter on the moon, right, with a couple of solar panels on it. How long is it going to last without plugging it into the mains? I don't buy it.
Right.
All right, let's have a look at the Curiosity rover. Now, this is a different beast altogether. It's much bigger, more sort of the size of a car, much more highly powered, and this is the one that there was big fanfare a few years back when it allegedly landed on Mars, and we're going to look at that in a minute. But it uses a different power system, Andrew. This is using some sort of nuclear isotope power system.
The system, as I understand it, is basically uses some type of thermocouple, doesn't it, where you have the cool temperatures on the outside of the vehicle, and then you have the warmer temperature which is created by the radioactive decay from the isotope, and then you have a thermocouple set up between those 2 points, and that provides a current from the temperature difference. That's my understanding.
So
how that works.
Right. I've said here, while it seems plausible that a radioisotope electric generator could provide enough energy to power Curiosity rover, the Opportunity rover seems unfit for purpose by comparison. So let's just talk about the testing of these vehicles, because I've worked in my career as an engineer for the best part of 20 years and been involved in a lot of testing of products. And what I set out in the document is the philosophy that you use when you test products, is in that you have a separate test department and design department, and they're not really supposed to collaborate with each other, because you look at the requirements of the product. The test department will have its own engineers who devise the test procedures and carry out the tests separate from the designers, because there's always a chance that both sets will interpret the requirements incorrectly, and therefore it will pass a test without complying with the requirements. So there's all these things, and the videos that I've seen put out by NASA, there just seem to be one big happy family there. It doesn't seem that they're doing independent type of testing that I could see in their videos.
Well, they appear to show some scientists working hard to develop the rovers, but there's absolutely no documentation, no film footage of any of the development stage, or very little documentation and footage of the development of the rovers. And particularly, of course, the landing stages. I think it's the Curiosity rover had a very complicated 6-stage landing procedure.
That was, you know, we were discussing this earlier, and it does. I mean, from the videos they put out, it does look more like a PR exercise, and sort of, you know, patting themselves on the back, rather than some type of rigorous, you know, type of audit test where somebody is actually pinning these people down and checking that the systems meet the user requirements, you know, and that these systems are working as designed, you know.
I would expect a device like a rover to probably have several test specifications, each with hundreds, if not thousands, of tests to test against mandatory requirements, all signed off. But all we've got is a few videos from NASA. We can look at this one that they've put out, which was the drop test.
Oh yeah.
So we'll just have a look at this now.
5, 4, 3, 2, 1, fire.
So big fanfare, but what actually happened in that test? We saw something kind of lowered to the ground. Now, I've worked on systems which lower nuclear weapons into Trident submarines, right? And when we're testing that type of equipment, they're operating within, let's say, certain acceleration parameters and velocities. So you don't know that the thing's passed the test until you've got your test data back. Because what we used to do when I was at Faslane nuclear base, we put a 125-ton bag of water on the end of a crane and we drop it and then see if the braking system worked, and the accelerations will be measured, and then you wouldn't know until afterwards it's passed the test. You certainly wouldn't stand there clapping your hands. So it just, I don't buy it, you know.
It's right. I mean, if you watch that video, which I think is the test of this so-called sky crane drop mechanism which was allegedly used in the landing of the Curiosity rover. Yeah, I mean, it's like, oh, you know, it's like they've set up this rig, they've dropped something down, and they're looking up, oh, it hasn't broken, you know, therefore it's passed the test, you know. So that's what it looks like to us. I mean, you know, again, but there may be things that we can't actually see, but why can't we see more of those, somebody, you know, going through a list of checkpoints, you know, on a list, or like you say, measuring the acceleration of this component and, you know, the stress on that component, you know, what have you. We don't really see that, certainly not in the video. So again, and I think one of the things we're talking about, Richard, isn't it, is having some type of independent verification of NASA's claims.
Now let's come on to the outside area where they've allegedly used to test some of these rovers, known as the Mars Yard. So we'll just put some photographs up on the screen, and it's not the most impressive test site in the world, is it? I mean, what are your thoughts on it, Andrew?
Well, like you say, I mean, you know, it's one of those things, a bit like the Apollo pictures. When you look at them, they seem plausible. When you look at this, it seems like a plausible test area. But when you were pointing out, for example, that your own experience of going on test sites for some of the projects you've been involved in the past, and I've been on one or two of those sorts of projects as well. Probably not to the extent that you have, but yeah, it's true. You would have some more. You'd have more security. You know, you'd have more equipment sort of set up. It doesn't really look that
as you said earlier, you're talking each of these rovers, whether they're the test rover or the actual rover, you're talking multi-millions of pounds each. So there's not even, doesn't even look like there's any security there, so someone could just come in and steal it. So it just doesn't look like a comprehensive environmental testing site to me. Right, well, we've yet to come on to the most damning evidence, by the way. I mean, this is really just background what we're discussing at the moment. A rocket was launched at Cape Canaveral on the 26th of November 2011, and it got to Mars in August 2012. And this was filmed, or the Curiosity team sitting behind their consoles, which I find a little bit intriguing, because you've got all of these operators sitting behind consoles, supposedly looking at different parts of the mission of this craft as it's going towards the surface of Mars. But we know that a signal from Earth to Mars takes at least 3 minutes, so that's 6 minutes to get there and to get back. So if they were to modify any sort of part of the mission, it's a 6-minute feedback loop. So they're not looking at a live image. So I would have thought the vast majority of the program to land the thing, or if not all of it, would have to be completely pre-programmed and automatic. So I asked the question, well, what are all these operators doing?
If there's some buffeting in the atmosphere that this thing is going through, and they need to respond to it, then it's going to be 6 minutes later when this thing has already gone thousands of miles off course and potentially crashed. So they must have done some very good modelling and had a lot of good data as to how that thing was going to come down. I mean, I think when they have the press conference, which we're recommending that people watch that that landing press conference. We're going to talk a bit more about that in a minute. But they say, I think within that, they say they landed within about 50 metres or something, or 500 metres of the target area, which is, if you're going all the way to Mars, that's pretty incredible.
Right.
You know, are they just good engineers and skillful people, you know, with the mechanics and so on? But
there is a video which allegedly shows the craft kind of going down to the Martian surface, and then there's another photograph which they claim to be Curiosity rover on the end of a parachute. So how would, because people who would say that these missions did land on Mars, they would cite these two pieces of evidence, both the video and the photograph of with the parachute out taken by a Mars orbiter. In
some ways, the difference between the Apollo deception and the rover's deception is CGI, which is why the pictures we're seeing now are so much more convincing. JPL themselves, the Jet Propulsion Lab, have actually developed software called Virtual Presence in Space technology, which is cutting-edge CGI, beyond anything we've seen in the movies. Isn't anybody wondering why?
There's a conference, and I recommend you watch the whole conference. And this was the 2012 landing briefing, so it's the conference after they've supposedly successfully landed the Curiosity rover on Mars, and one of the main speakers there was this guy Adam Steltzner. So they were being asked questions by the press, and let's just have a look at this little clip of Adam Steltzner, who's one of the lead engineers. I think he supposedly devised the
sky crane,
the method by which the thing is actually landing.
That's right. He was the guy who sort of pushed for the sky crane system to be used. Yeah.
Right. So let's just take a look at this.
Adam, tell us about the landing.
All right, Greg. I can't tell you too much about it. I mean, it looks good. I'm being a little flip. In short, it looked extremely clean. We touched down in conditions that were on the more benign side of our nominal expectation. By the way, I want to preface everything. This is preliminary data scooped with the sieve in the cacophony of the control room during the celebration, right? And largely by my good friend Miguel San Martin, who's somewhere out there, I hope. At any rate, very nominal, remarkably good. Our navigation error was on the low side of our expectation.
What? I have to ask you, what kind of file type? Can you tell us about the image file type and compression that was used to send this very important couple of thumbnails back from Mars?
Yes, unfortunately, I absolutely cannot.